Hey, it's Mr. E here, and our aim for this video is what are the characteristics of a normal distribution curve? How do we apply these characteristics? Below are Tim Tebow's yards rushed throughout 11 games in the 2011 season. So these are the games he started. The mean and standard deviation are also provided. As a warm-up, I want you to answer this question. In how many games did he rush for yards within one standard deviation of the mean? So think about that. Pause the video. All right, so let's think about that. In how many games did he rush for yards within one standard deviation of the mean? Well, in order for us to figure that out, we have to figure out what's minus one standard deviation and plus one standard deviation. So minus one standard deviation is 26.97. Plus one standard deviation is 86.31. What the question is asking us is how many games are within this range? And how many games did he rush for yards within one standard deviation of the mean? How many of these 11 games fall within one standard deviation of the mean? Well, that would be game 1, game 2, game 4, game 5, game 6, game 8, and game 10. All the other games are outside of this range. So that's a total of 7 games. In 7 of those games, he rushed for yards within one standard deviation of the mean. Here's another one. In what percentage of his games does he rush within one standard deviation? In other words, what percentage is those 7 games out of the 11 games? Think about it. In what percentage of his games does he rush within one standard deviation? So now it's a percent question. What's 7 out of 11? 7 out of 11, percentage-wise. Well, that's approximately 63 point, to give you an exact number here, 7 out of 11, approximately 63.6, so we'll round it off to 64%. So 64% of his games are within one standard deviation. 64% of his games are within one standard deviation. Because he played 11 games, and in 7 of those games he's within one standard deviation. And 7 out of 11 is 64%. Okay, what is a normal distribution curve? A normal distribution curve or normal distribution is a very important statistical data distribution pattern occurring in many natural phenomena such as height, blood pressure, lengths of objects produced by machines, etc. Certain data, when graphed as a histogram, creates a bell-shaped curve known as a normal curve or normal distribution. So this is just something that occurs naturally. And let's go over the different parts of the normal distribution curve. So here's what we got in the normal distribution curve. These numbers here at the bottom represent standard deviation. So obviously at 0 standard deviation we're going to have the mean. That's the only part where you have no standard deviation. Remember, standard deviation is a measure of fluctuation from the mean. So if you have 0 standard deviation, that's where the mean goes. Okay, so what is a normal distribution curve? In a normal distribution curve, you have most of your data concentrated within the mean. So to be more exact, within one standard deviation of the mean, you got 68.2% of your data. And I got that 68.2 by adding 15, 19.1, 19.1, and 15 because that's within one standard deviation. Now, within two standard deviations, so I'm going to add up all of these percentages. I got 95.4% of my data. So 90, that's my percent sign. I got 95.4% of my data. And within three standard deviations, you're going to have close to 100% of your data. So that's a normal distribution curve. A good question to ask is how did they get this curve and how did they get these percentages? That's a very loaded question beyond the scope of this video and maybe even our course. I do encourage you to search for that in the internet, or we can talk more about it in class tomorrow. But for now, I think you got the information that you need to answer some of these questions that you'll see on your advanced algebra / trig regions. Okay, so here's a type of question that you'll see. The amount of mustard dispensed from a machine at the hot dog emporium is normally distributed. So once you see that, that's a dead giveaway that you're going to be working with the normal curve. With a mean of 0.9 ounces, so let's write that down, the mean is 0.9, and a standard deviation, that's my sigma, so standard deviation of 0.1. That's not a G, that's my sigma sign. I know I got terrible handwriting. If the machine is used 500 times, approximately how many times will it be expected to dispense 1 or more ounces of mustard? Alright, so we're going to be using our curve, and here's what we know. We know that at no standard deviation, that's the mean is 0.9, so that's going to go right here, right in the middle. And within one standard deviation, so if we go back, so minus one standard deviation, that's 0.8, plus a standard deviation, that's going to be 1. 0.9 plus 0.1 gives us 1, 0.9 minus 0.1 gives us 0.8. And we can also arrive at these other numbers from the standard deviation. Alright, so going back to our question. If the machine is used 500 times, approximately how many times will it be expected to dispense 1 or more ounces of mustard? So think of it this way. How often does it happen, percentage-wise, that the machine dispenses 1 or more ounces of mustard? Well, let's look at our curve. It happens here that it's 1 or more. Because you have to be at 1 and then everything greater than 1. So we're going to add up these percentages, and that's going to tell us percentage-wise how often this happens when it dispenses 1 or more. So let's add 9.2 plus 4.4 plus 1.7 plus 0.5 plus 0.1, and we get 15.9. So that means that 15.9% of the time this machine dispenses 1 or more ounces of mustard. But that's not the question. The question is if the machine is used 500 times. So what we want to know is what's 15.9% of 500? So we could convert this to decimal by moving this 2 places to the left. So we get 0.1159 times 500. Just think of the word of as a multiplication. So we get 1.59 times 500, and we get 79.5. So 79.5 times out of that 500, this is when the machine dispenses 1 or more ounces of mustard. Now just think about it. Does it make sense to say 79.5 times? Not really. So we're going to have to round it off, and let's round it off to 80. So we'll say that 80 out of those 500 times the machine dispenses 1 or more ounces of mustard. Okay, here's an example that you could try. You're going to be using your normal curve. If you don't want any hints, stop the video now. If you want a hint, you could keep watching. Okay, so it says that the mean is 72.3. So the mean is 0 standard deviation. So that's going to go here. So 72.3. And then you can figure out what the other numbers are within 1 standard deviation, within 2 standard deviations, within 3 standard deviations by adding or subtracting, if you're going backwards, the given standard deviation. So 72.3 plus 8.9, that's 81.2. And I'll stop there with the hints. Okay, I hope this video helps. Take care.